So in today's lecture, we are going to discuss Ruby laser. So Ruby laser, that was first laser in the market, and this laser was discovered in 1960. Ruby laser, that is a solid state laser. Why this laser is a solid state laser? Reason is the active medium of Ruby laser, that is in solid form. So if the active medium is in solid state, then that is a solid state laser. If it is in liquid state, then that is known as liquid laser. If it is in gaseous form, then that is known as gas laser. But in Ruby laser, this active medium that is in solid state, that is the reason it is a solid state laser. The next feature of Ruby laser is it is a 3-level laser. As we have already discussed that a laser system that is either a 3-level laser or a 4-level laser. So in Ruby laser, since 3 energy states are participating, so this laser is known as a 3-level laser. The output of this laser, that is in pulse mode. Pulse mode means you are not going to get continuous output from Ruby laser. You will get a laser pulse from Ruby laser. Then for a particular duration, there is no output from the laser. It means you will get the output from a Ruby laser in the form of spikes. You will not get continuous output from Ruby laser. The next feature is the output of Ruby laser, that is in visible range of electromagnetic spectrum. The output wavelength of laser beam from Ruby laser is 6943 angstrom. So these are some general features related to this Ruby laser. Now we are going to discuss the construction, working and energy level diagram of Ruby laser here. So as we have already discussed in our previous lecture, that the main components of any laser system are active medium, pumping source and resonant cavity. 3 main components are there: active medium, then pumping source and then resonant cavity. So this is the construction of this is general diagram of a Ruby laser, where one by one we will discuss all these 3 components. The first component is active medium. Since it is a solid state laser, and in all solid state lasers, the active medium that will consist of 2 parts. One will be the host material, which will provide the base, and the second will be the impurity ions, which will be added into that host material. And actually those active ions, they will participate in light amplification. So in Ruby laser, this is the active medium. This active medium is basically Al2O3 crystal, that is a pink ruby crystal, Al2O3 crystal, and that pink ruby crystal is basically the host material there, and that host material is doped with chromium ions. So this is your pink ruby rod, pink ruby crystal, and in that pink ruby crystal, Cr3 plus ions, a percentage of 0.005% of chromium ions, they are added, they are doped in this Ruby laser. So Al2O3, that will provide the base, and in that Ruby crystal, some of the aluminium ions, Al3 plus ions, they will be replaced by Cr3 plus ions. And these Cr3 plus ions, these chromium ions, basically these are the active ions which are participating in light amplification. So this is active medium. The second one is pumping source. So in this solid state laser, in order to get population inversion, we are using optical pumping. Means by providing light, by providing energy in the form of light photons, we will achieve population inversion here. So in order to provide that optical pumping means with the help of a light source, you will achieve population inversion. So here you have a helical xenon flash lamp, and through this helical xenon tube, you will provide light photons. Those light photons will strike over this active medium, and then population inversion is achieved. So active medium, that is pink ruby crystal dotted with chromium ions, and pumping source is an optical pumping source, a helical xenon tube through which light photons are provided. Now the third component, which you know that a combination of 2 mirrors. Third component is resonant cavity. So what you have, suppose this is pink ruby rod, pink ruby crystal, in which some chromium ions are added. Then it is connected to an optical pumping source. Now the 2 ends of this ruby rod, they are made silvered in order to get that resonant cavity. this one end, suppose this end is fully reflecting, then the other one is partially reflecting. So the combination of these two reflecting ends, that will form the resonant cavity here. So the third component is these two reflecting ends. This end is fully reflecting and this one is partially reflecting, and you will always get the output from partially reflecting end. So these are the main components, and one additional component is there. In this ruby laser, a large amount of heat will be produced. So because of that reason, in order to remove that excessive heat from this laser system, continuously water is circulated. That water will act as a coolant here. So here we have a glass tube, and a coolant or water is circulated through this ruby laser in order to remove that excessive heat. So this is construction. Now the next one is energy level diagram. So as we have discussed here, that this ruby laser is a 3-level laser. 3 energy states are participating. This one is ground state, and this energy level diagram is basically for chromium ions because they are the active ions here. This is ground state, this is metastable state, and this is excited state. Initially in this active medium, most of the chromium ions are present in ground state. Now with the help of this helical xenon tube, light photons will strike over it. Now out of all the photons which will be provided by this optical pumping source, only the photons of a certain wavelength will be absorbed. Only the photons of wavelength 5500 angstrom, these photons are required in order to move from ground state to excited state. It means out of all the photons, only the photons of green light, that is wavelength 5500 angstrom, only these photons will be absorbed, and after that, after absorbing those photons, chromium ions will move from ground to excited state. Now when these chromium ions, they will reach into excited state, then they are highly energetic. Their energy is very high. Now these highly energetic chromium ions, they are having high kinetic energy. Now these chromium ions, they will collide with the crystal lattice, and when they will collide with the crystal lattice, they will supply some part of the energy to the crystal lattice. So after supplying some part of the energy to the crystal lattice, these chromium ions, they will come down because the energy will decrease, so they will come down to this metastable state. Now this metastable state, it is having a longer lifetime as compared to excited state, and this lifetime is 10 raised to power minus 3 seconds. It means from excited state, after colliding with the crystal lattice, they are coming down to metastable state, and that metastable state is having a longer lifetime. It means now they will start accumulating in metastable state. So state 1, its population is decreasing because these chromium ions are continuously pumped to 3. And state 2, its population is increasing because from 3 chromium ions are coming down to 2. Now a time will come when there will be more chromium ions in metastable state as compared to ground state. And that particular time when you have more chromium ions in metastable state with respect to ground state, that will be the population inversion state between 2 and 1. Now the chromium ions which will complete their lifetime here, they will automatically come down to 1. If they will automatically come down to state 1, they will emit photons of extra energy. And the photons which are emitted here, they are having this wavelength 6943 angstrom. These photons, they are released due to spontaneous emission. These photons will start moving inside the active medium, and since these two ends are reflecting, so these photons, they will be reflected at these two ends, and when these photons, they will come back into the active medium, they will interact with more chromium ions of metastable state, and because of that interaction, they will trigger stimulated emission transition. They will help to achieve this stimulated emission transition. It means one photon that will convert into 2. Now these two, they will start moving inside the active medium, reflected by these two, and then again those 2 photons, they will interact with 2 more metastable state atoms, and they can trigger 2 more downward transitions. It means that multiplication of photons will go on, and when the energy of those photons, when you will get large number of photons, then the energy will become very high, and those photons, they will escape from this partially silvered end in the form of a laser beam. So basically 4 transitions are there in Ruby laser. The first transition is from ground to excited state by absorbing photons of this wavelength. So now, basically, in this Ruby laser, a large amount of heat is produced. So there are two main reasons for that heat. First one is when you are providing this pumping energy, or pumping source is giving photons, only photon of this wavelength are utilized, and rest of the photons, they will be wasted in the form of heat. Then excited chromium ions, they are colliding with the crystal lattice. Again, that will produce unwanted heat in that laser system. So first transition is from ground to excited, then from excited to metastable state, and then from metastable state to ground state. First spontaneous emission, and then it will convert into stimulated emission. Then there will be multiplication of photons, and you will get laser beam. So that is a working process of Ruby laser. And there are tremendous application of this Ruby laser in different fields. For example, in case of material processing, like in laser cutting, laser welding and drilling, Ruby laser is utilized. This Ruby laser, that is also used in the formation, in the construction of holograms. So this Ruby laser is having different applications in different fields. Thank you.